So this is the initial clustering, or you can consider the cluster of the movies which are more similar. Now what I will do, we will have to go to the next iteration. So the next iteration is nothing but you have to first find out uh, the new centroid for this cluster 1 and cluster 2. So for that, let's say we are going to the next sheet. So here again I have to just copy this. So here I only copy this much, your film name and your scaled features and the cluster informations. Okay. Now right now I no need of this distance calculation. So because our new centroid will be calculated, and based on that only again we have to calculate our distance. So here first let us just distinguish these two clusters. So what I will do, first let us just sort this entire thing based on the clusters. So here I just use the sort, and here I can use custom sort, where I can go for, let's say, okay, I have to mention that there are levels. So okay, so I'm just considering the levels, then C1. So largest to smallest, because I need all the values all once. So here you can check in my cluster 2 I have only 1, 2, 3, 4, 5 movies. So based on this I have to just calculate my new centroid. So what I will do, I am calculating the new centroid. So here if I calculate my centroid C1 and C2, these are the updated C1 and C2, and the feature values I have to put over here. So right, then equal to average. So again the same thing, you have to consider all values till 1. Okay, then hit enter. So this is the new centroid for your new cluster. And finally you have to go for the second one. So here also I will apply average. Here also you select these values, hit enter. So that is your new centroid, and you just use for others. So this is the new 2 clusters. Now based on these 2 cluster values you have to calculate the distance. So again I will just calculate the distances between these 2 category or group of films. So distance from cluster 1 and distance from cluster 2. So again you have to use the square root. So let us just copy paste the entire formula from the previous sheet. I have to do, I have to just change the numbers, nothing else, cell numbers basically. So here put this value, then you have nothing but here it is Q. So if I put this Q, Q1, Q2, so basically Q2, so this will be B2, this is in QR, C, S, so this is also 2, go to the D2, T2, T2, this is will be E2, and finally U to F2. Again, you just hit enter. Okay, you have to put, I guess, last one, U2. Okay, bracket. Again, I guess some term mistake. So let us just check again what are the things are there. First Q2, okay, Q2, then R2, then S2, D2, T2, and F2. Okay, maybe because of the same line they are, that's why this is happening. So what we can do, we can just shift these values to the corner at the end. So now I have to just change it. So this is nothing but same B153. So B153 and hit enter. Just escape out of this. Okay, again I have to rewrite the formula, I guess. These values first remove, then recalculate. So if I put the formula again, copy paste, and in place of these values again I have to just change 153. So this is B, this is also B, 153. So B2, C, 153, C2, and D, 153, D2, then E, 153, E2, finally F, 153, and F2. Okay, I have to separately, I guess, define these values. B150. Here is the mistake. Enter. Average AVRH. So while working with the Excel, you have to just make sure that your values are right, or you are selecting the right cells. So here also it was 146 to B146 to 150. Okay, now it's right. So this was a kind of a mistake that was done by me. Now just check, it is showing the right answer. Okay, and if you just hit enter button, so you will get the distance from all these values. Again, similarly, I can apply for the second cell also. So in this case, I have to just change to 54. Nothing again, and these are the distances that can be easily calculated. So if I just drag the value, it's 153. I guess that's changed. Yeah, 153 and 154. So this will be 153. So again, a similar logic you have to just apply, and you have to identify the new cluster sets. So here also again, if this value is less than equal to this, then it will be 0, it will be 1, otherwise it is 0. So I am using the opposite logic in this case. And finally, here also the same, the opposite thing you have to do, 1 minus the cell value, just create. So finally, after 2 iteration, you just check there is no change in the cluster information. So now we can settle with this clusters. So we can go, let's say another clustering, still the answer will not change. Now how these two clusters can be interpreted? Before that, we have to calculate some of the matrices that say within cluster SSE or sum of square, that indicates that how closely they are situated in a particular group for a particular member. Another thing is the how these two groups are apart from each other. These two informations are critically, because you always want that these two groups, they should not overlap. So that's why they are between two cluster SSC they should be higher, and within cluster SSC should be less. And then we will go for the Shillert score. So let us just calculate the within cluster SSC and between cluster SSC. So SSW I'm just writing, and SSB. So within cluster SSC is nothing but you have to just calculate all the cluster error. So that straightforward you can consider these distances. So already we have calculated all the distances, so I can just take the square and just add them, and we can get a single unit that will indicate how much close these values are within. So this SSC, SSW, SSB is useful when, let's say, you are comparing two clustering strategy. Let's say you have generated 2 clusters, 3 clusters. In that case, how well, what is the quality of the clusters, that can be easily understood by comparing these two values, SSW and SSB. So let us just understand how to calculate, because already we have calculated this distances. So we have to just take the square and just add them up. That is the process for calculating SSW, and you have already the two centroids. So if you just take the square and just add them up, then if you just find out the distance and just take the square, then you will find the SSB. So what I will do, I am just taking the square and just taking the sum of these values. So I have to just write sum and then so let us first, for this is SSW for C1, this is for C2, then we have to calculate total. So for cluster 1 it is sum then SQRT of these values. So I'm just considering selecting all the values, and then we just put. So this is the total sum of square for cluster 1. Now for the cluster 2, similarly, I can use S not okay, and here it is square only. I just, so this is nothing but the square you have to just take, individual square. So take a square and then sum. Here also same, sum, and then you go to the members, you put a bracket, again double bracket, and just take the square of it. So this is the sum of square within, and this total is sum of these two values. And between, that is nothing but you have to just consider these two. You have to just find out the distance, and then you have to just take square. So basically sum equal to sum and this minus this square, or what I can say, I can simply just write the formula, so it will give you a better understanding how I am doing this. So minus this, take a square, plus again this minus this, take a square, plus this minus this square, plus again this minus this square, plus this minus this. So this is a sum of square between the two clusters, and this is a total sum of square, within for these two clusters. So I'm just, if I just mark them into two, okay, with the color. So these are the two useful results for me, which indicates how much two clusters are apart from. So SSB is nothing but indicating how the two clusters are apart from each other, and how the members are similar, that can be indicated with SSW. Now another thing is that you can calculate the silhouette score. Now in that case, what you have to find out, let's say you have to calculate individual silhouette score for all the members, then you have to just add this value. So I'm just giving one simple instance or simple example of that. So let's say here some silhouette score, I'm just calculating, equal to, so first of all, it is nothing but the ratio of your 1 minus your within distance and between distance, or within sum of square and between sum of square. So first of all, let's say if I just simply just write this thing, that okay, for this particular point, let's say I'm just calculating for one point, then it will be easy for you, because then what you have to do, you have to just add. So and the silhouette score can be easily calculated like this. So equal to 1 minus, so let's say this is my 1 point, so the centroid of this point already known to me, so how much nearer to this point, so let us just calculate. So this distance will tell you about that. So DC1, so that is 3.93, so I'm just taking this value and divided by this point. So this is nothing but the silhouette score for this particular members, okay, for its cluster. Now with respect to, I have to mention this with respect to cluster 1. Now for the same, you have to calculate for each term. So let's say I'm calculating this term C2 by H2. So H2 is fixed over here. Okay, no, not fixed for this case. So first enter and then calculate for all the members, because already I know who are the member of this cluster. So till now, so these are the silhouette score for each members. Now similarly, you can calculate the silhouette score for these points, or then let's say 1 minus, in that case it will be this divided by this, means distance from its own centroid divided by distance from its nearest centroid. So if I put this, these are the silhouette score. Now if you just check this value, so one particular member, if it is nearer to, definitely it is nearer to its own cluster, and if you just check this formula, nearest to, so this value is definitely less than this, and this ratio always less than 1. So when if you are just negating from this value, so definitely that will be also less than 1. So this silhouette score, it varies from 0 to 1, and if it is more, means the higher value is desired, as let's say this G2 particular value, if it is it's reducing and H2 is increasing, so definitely this G2 divided by H2, this entire term will be decreasing. In that case, 1 minus that decreased value will be definitely increasing with the distance. So higher silhouette score indicates that a particular member is very nearer to its centroid and far from the nearest cluster centroid. And this way also you can easily understand the cluster quality. So let us just compare two values. Let's say if I just randomly take this value, this alone film, that is Silhouette score is 0.65, and on the other side for cluster 2 you have Bang Bang, that is 0.45. So we can easily tell or easily conclude that this alone film is more similar or more suitable for cluster 1 in comparison to Bang Bang, that is again in comparison to your cluster 2. So cluster quality wise, you can consider by just taking a sum of these things and just try to find out, or just by just comparing the Silhouette score, you can easily find out who are good, who are actually a proper member of that particular cluster. So again, if I just compare within cluster members, so just check, if I just check with alone with NH10, this film, so NH10 has a higher Silhouette score, so definitely it is more nearer to its cluster in comparison to alone. So these kind of comparison can be, or this kind of analysis can be done with the help of Silhouette score when you are doing kind of a within cluster or within cluster member analysis. So also after this analysis, once you identified these are the particular members of a group, you can do kind of a EDA, exploratory data analysis, and apply some mean mode median to find out what is the average characteristics of the members for a particular cluster. So let's say if I just check for this particular film, so definitely I can understand that who are more similar to, in comparison to, let's say, who are more deviated or based on these mean values or the member values. Okay, hope you understood this basics of your clustering with the help of K-means algorithm, and definitely we have two matrices that helps us to dissect the clustering approach. One is that within cluster sum of square and between cluster sum of square, and definitely the Silhouette score, which help us to identify how well the members are part of a particular cluster. So definitely after this we will be moving towards the association rule mining. Thank you for watching this video.